consider question number 11 now. We have compounds A, B, C, D, and E. Now they're asking us to compare the boiling points of what? A, B, C, D, and E. All have the same molecular weight. Now you know boiling point depends on what? The molecular weight as well as what? The strength of intermolecular interactions mainly, right? So then if they have the same molecular weight, we have to think about what? The strength of what? Intermolecular interactions. Now you can see in E, that compound E has what? Hydrogen bonds. It is able to form hydrogen bonds because it has the OH group. But D and C, they can form what? Dipole-dipole interactions because they have what? Aldehyde group. C and D have what? The aldehyde group in common. Therefore, they can form dipole-dipole interactions. But the strength of normal dipole-dipole interactions is less than what? Hydrogen bonds. Therefore, obviously, E should be having the highest boiling point. Now, who has the lowest boiling point? The one who has only what? London dispersion forces, right? Van der Waals interactions only. Because now, if you consider A and B, they don't have anything except what? London dispersion forces. So, therefore, they should be having the lowest what? Boiling points. Now, if you consider all the answers, can you see what answers we can remove? You know, now you can't directly remove an answer, but let's think about this first. If you consider A and B, if you consider compound A and B, the surface area of compound A is greater than what? Surface area of compound B. Because it's stretched out, right? Then when the surface area of A is greater than that of B, the strength of London forces in A is greater than what? The strength of London forces in B. Therefore, the boiling point of A is greater than what? The boiling point of B. Is that clear? Right. So, seeing that observation, we can remove the answer 3. And answer 4 can be removed because boiling point of A is greater than B. That's all. So, for now, we can remove 3 and 4. And then look at 5, for example. They have mentioned the boiling point of D is less than the boiling point of what? A and B. That's wrong. If you consider the structure D, it has what? The aldehyde group. So it has to have a higher boiling point compared to A and B, right? Then 5 can be removed, right? And then 3 can be removed, 4 can be removed. Then we have only answers 1 and 2. Let's compare 1 and 2. Now, can you see how easily you can get the answer? Can the boiling point of C be equal to the boiling point of D? Impossible, right? Boiling point of C cannot be equal to the boiling point of D. Why? If you consider C and D, they have the aldehyde group in common. C and D have the aldehyde group in common. Observe the paper, right? C and D have the aldehyde group in common, but C has a higher surface area than what? D, which means the strength of London forces within C is greater than what? The strength of London forces within D. Therefore, the boiling point of C is going to be greater than what? D. Now, that can only be seen in what? 2. That clear? Therefore, the answer is going to be what? The second one. I hope you understood this. Logically, you can do this question logically, right? Good question. 12th question. Question number 12. The increasing order of the covalent character of the chemical species sodium chloride, sodium sulfide, potassium fluoride, potassium chloride is. Okay, let's see this. Increasing order of the covalent character, right? How can you do such a question? Now listen. Polarizing power and polarizability. These are very important words. Polarizability and what? Polarizing power. You talk about the polarizing power of the cation. We talk about the polarizing power of the cation. And we talk about the polarizability of the anion. It's a quick revision of the theory, right? Okay. Now, when the cation, these are two very important points. When the cation is small and highly charged, when the cation is small and highly charged, polarizing power increases. Polarizing power increases. Polarizing power increases. When the polarizing power increases, covalent properties increase. Covalent properties increase, right? When the polarizing power increases, the covalent properties increase. When the covalent properties increase, ionic properties decrease, right? Ionic properties decrease. When the ionic properties decrease, thermal stability, right? Thermal stability like properties. Look at the properties from the book. I'm not going to mention everything. Thermal stability like properties are going to decrease. That clear? So when the cation is small and highly charged, the polarizing power increases, covalent properties increase, ionic properties decrease, thermal stability decreases. When you talk about polarizability, we talk about the anion. When the anion is what? Highly charged, and what? Large in size, large, highly charged and large. What I mean by highly charged is it has a higher charge. That clear? So when it's highly charged and large, what's going to happen? What's going to happen is this: the covalent properties are going to increase. Covalent properties increase. Props increase, right? Because the polarizability increases when the anion is highly charged and large. Then the covalent properties increase. Is that clear? Right. When the covalent properties increase, the same story follows. Ionic properties decrease, thermal stability like features decrease. Right. Now you got an understanding of the theory, right? I didn't fully explain this. I have to draw the electron clouds and stuff. I don't do that, right? That is the theory note. But now here, a rough understanding. So please go through the theory note and then fully understand and confirm this, right? Okay. Right. Look at the next question now. So we have question, okay, same question. We have to do the question, right? So I explain the theory. So let's compare these now. Now you learn the theory, right? Anion is large. If the anion is large and highly charged, what's going to happen? Polarizability increases, then covalent properties increase. When the cation is small and highly charged, polarizing power increases. When the polarizing power increases, the covalent properties increase, right? So let's compare now. Actually, the answer is the third one. I'll explain it through the answer, right? Kf, then we have KCl, sodium chloride, and then we have what? Sodium sulfide. Now listen. If you compare potassium fluoride and potassium chloride, what can you say? Why is the covalent property of potassium chloride greater than potassium fluoride? Covalent properties increase, right? In this direction, covalent properties increase. The same cation is there, right? Same cation. We have the same cation, potassium plus, but anion is different. Can you see whose anion is larger? Cl minus is what? Larger than what? F minus. When Cl minus is larger than F minus, the polarizability of what? Cl minus is greater than F minus. Therefore, KCl has what? A higher covalent character compared to what? Kf. Very easy. Now we have to compare KCl and sodium chloride. Let's compare KCl and sodium chloride. What can you say? If you compare KCl and sodium chloride, what can you say? Anion is the same. Anion is the same. But what can you say about the cations? Sodium plus is bigger than what? Sorry. Potassium plus is bigger than what? Sodium plus. So what's the meaning? If potassium plus is bigger than sodium plus, what can you say? Remember I said that covalent properties increase when the polarizing power increases and polarizability increases. You know that polarizing power increases when the cation is highly charged and what? Small. Sodium plus is smaller than what? Potassium plus. Therefore, the covalent properties of what? Sodium chloride should be greater than what? Potassium chloride. Now I think you can understand that. That clear? So that's the point I discussed now. Now we compare sodium chloride and what? Sodium sulfide. Very interesting. Sodium chloride and sodium sulfide. What's the fact there? You know the sulfide ion is bigger than what? The chloride ion, right? Sulfide ion is bigger than what? The chloride ion, and we have the same cation. Sulfide ion is bigger than the chloride ion, therefore what? Polarizability of what? Sulfide ion in sodium sulfide is greater than what? Sodium chloride. Therefore, the covalent properties of sodium sulfide is greater than what? Sodium chloride. Very easy, right? That's how we get the answer. So the answer is the third one, right? Yeah, now let's see. All right, let's look at question number 13 now. Standard combustion enthalpies of hydrogen, carbon, CH3OH at 290 Kelvin are minus 286, minus 393, and minus 126 kilojoules per mole respectively. Enthalpy of vaporization of CH3OH is plus 37 kilojoules per mole. Enthalpy of formation of 1 mole of gaseous CH3OH at 290 Kelvin is. So we have to form gaseous CH3OH. So read each and every statement, right? So to form what? Gaseous CH3OH. Gaseous. So I should start with what? Carbon solid, then hydrogen gas, then oxygen gas. Right. Can you see? Here I have 4 hydrogens. Then I should have what? 2 hydrogens here. 2H2 gas here. Now this is because I'm going to form 1 mole of CH3OH gas, right? I had to form what? 1 mole of CH3OH gas. Then such that I form 1 mole here, I have to adjust the atoms. I should have 2 H2 molecules here to form what? CH3OH gas here. And what? Half O2 gas. Then oxygen is balanced. Here I have O2, but if I multiply by half, it becomes 1 oxygen. Right. Now let's see. This is what? The enthalpy of what? Formation, right? Now, CH3OH gas can be formed from what? CH3OH liquid. So this is the enthalpy of vaporization. Enthalpy of vaporization. What's the value that they are given you? Enthalpy of vaporization that they are given you is what? Plus 37 kilojoules per mole. Right. Now, they have mentioned this. They mentioned the standard combustion enthalpies of hydrogen, carbon solid, CH3OH liquid. That means you have to combust with what? Oxygen. Carbon reacts with what? Oxygen and forms carbon dioxide. So we have carbon dioxide gas. Hydrogen reacts with oxygen and forms what? Water. Right? Liquid. So carbon dioxide gas plus water liquid. Is it balanced? Not yet balanced, right? It's not yet balanced. So how can you do? Look at this. Here I have 1 oxygen. No? Half O2 means 1 oxygen. Here I have what? 3 oxygens. 3 oxygens here and only 1 oxygen here. Then what should I do? I should add what? 3 over 2 oxygens. Right? 3 over 2 oxygens. And then what? Multiply this by 2 to get 4 oxygens in total. Because here I have 2H2, no? Then I should get what? 2H2 here also, no? Here I have 4 hydrogens, I should get 4 hydrogens here. Then I get what? 4 oxygens here. To get 4 oxygens here, if I get 4 oxygens here also I should have 4 oxygens. Already here I have what? 1 oxygen here, then I need what? 3 more oxygens. 3 more oxygens means what? 3 over 2 times O2. That clear? Right. Okay, that's understood. And then, yeah, that's balanced, right? Now, what can I say? I can say CH3OH liquid combusts in what? Oxygen to form what? CO2 and 2H2O liquid. Now listen, here I have 1 oxygen, right? Here I have what? 4 oxygens. Then how many more oxygens do I need here? 3 over 2 O2 I need. Then I can get 3 oxygens. 3 oxygens here plus this oxygen gives you 4 oxygens. Here I have what? Already 4 oxygens. So it's balanced. So this is the enthalpy of combustion of what? CH3OH liquid. So they are given that value. What's the value? They are given that to be what? minus 126 kilojoules per mole. And what's this value? This value is given to be what? Yeah, combustion of carbon. Combustion of carbon is what? Minus 393 kilojoules per mole. Combustion of hydrogen. Combustion of hydrogen is given to be what? Minus 286 kilojoules per mole, right? Okay, that's understood. Now you can use Hess's law. There's another easy method. Now we can have arrows like this. Now here we can think of what? CH3OH gas becoming what? CH3OH liquid. Other way around, right? You'll understand why I'm doing this. We can think of the other way around. CH3OH gas becoming what? CH3OH liquid. Then heat is released. Then the enthalpy sign should be changed. That should be what? Minus 37 now. Minus 37, right? So arrows going in this direction. Arrows going in this direction, that means what? Anti-clockwise should be what? Equal to what? The arrows going in the clockwise direction. That means the sum of enthalpies in the clockwise direction should be equal to what? The sum of enthalpies in the anti-clockwise direction according to Hess's law. Then what can we say? I can say minus 393, right? Plus what? Minus 286 in this direction. What? Kilojoules per mole should be equal to what? Delta HF plus what? Minus 37 kilojoules per mole plus what? Minus 126 kilojoules per mole. Then I get delta HF to be equal to what? Minus 202 kilojoules per mole. I hope you understood this, right? Here delta HF is equal to what? Minus 202 kilojoules per mole, right? So that's the answer there. Yeah. Right, let's do question number 14, right? Now listen, phosphorus can be prepared in an electric furnace as given by the following balanced chemical equation. So I'm having 620 grams of what? Calcium phosphate, 620 grams. So what's the number of moles of calcium phosphate? 620 grams divided by what? 310 grams per mole. And I get what? 2 moles, right? I get 2 moles. What about SiO2? What's the mass that I have? I'm taking 180 grams. So 180 grams divided by what? 60 grams per mole. I get what? 3 moles. Carbon, how much do I have? 96 grams of carbon. 96 grams divided by what? 12 grams per mole. I have what? 8 moles of carbon. Right? P4. So they are saying 50 grams of P4 were obtained. No? Yeah, 50 grams obtained. So this is what it got, right? Yeah. Obtained. Now let's look at this question very simply, right? The stoichiometry between what? Calcium phosphate and silicon dioxide, SiO2, is what? 2:6. Silicon dioxide to carbon is what? 6:10. Therefore what? The stoichiometric ratio between these three is what? 2:6:10. If I start with 2 moles of calcium phosphate, I need what? 3 times that to react. No, I need 3 times of silicon dioxide to react, right? So I need SiO2. I need 3 times of what? SiO2 compared to what? Calcium phosphate to react. So what can you say? If I have 2 moles here, I should have what? 6 moles here. No, if I have 2 moles here, I should have 6 moles here. And here I should have what? 10 moles, no, for carbon. So if I have 2 moles, I should have what? 6 moles for SiO2 and what? 10 moles for what? Carbon. But that's not the case. Here I actually have what? 2 moles is there, okay, and what? 3 moles is there. But here I have what? 8 moles. Who is going to be the limiting reagent? Who's going to finish? Yeah, let's see. Here I have what? 3 moles, but I'm supposed to have what? 6. No, to completely react, right? In the stoichiometric order, I should have what? 6 moles, but I have 3 moles. The percentage that I have is what? 3 moles divided by what? 6 moles. So what? I have 50% of the amount that I need to react. No, actually I need 100%. That means I need 6 moles to fully react with calcium phosphate. That clear? But the problem is I have only 3 moles. That means I have only 50%. If we consider carbon, okay, I have 8 moles, but what? I need 10 moles, right? So I have only what? 80% of the amount that is required to react. Here I have 50% of the amount that is required to react, and here I have what? 80% of the amount that is required to react. Then who's going to be the limiting reagent? The limiting reagent is going to be what? Silicon dioxide, because it's present in the least. Only 50% of the amount that is required is present. That clear? So yeah, from that we can see silicon dioxide is going to be what? The limiting reagent. Then only answers 2 and 4 are possible for now, right? Now let's see. So they're asking, under these conditions, the limiting reagent and the percentage yield of P4 respectively are, right? Percentage yield of what? P4. What can you say? Right? Percentage yield of P4. Now you know, if I have 6 moles of what? Silicon dioxide, I should bring about what? 1 mole of what? P4. Clear? If I have 6 moles of silicon dioxide, I should have what? 1 mole of P4. The stoichiometry 6:1, right? If I have 3 moles, then I should have what? Half moles of what? P4. 6:1. That's going to be what? 3:half. No? That clear? We can think like this, right? If I have 6 moles, right, I can produce 1 mole of what? P4. Then what if I have 3 moles? I can produce what? Half. No? Think like that, right? Okay. So then what? Half moles of what? P4 is produced, no? Because I can only use what? 3 moles of SiO2, because SiO2 is going to decide the amount of P4 formed, because SiO2 is the limiting reagent. Okay? Then if I have half moles of P4 produced, I should have what? Number of moles times what? The molecular weight gives you the mass of P4 produced. Half moles times what? 124 grams per mole gives you what? 62 grams. So 62 grams of P4 should be produced. But actually I have what? 50 grams. No? Actually I have what? 50 grams. Then 50 grams that I actually have produced, I have actually produced what? 50 grams. But I'm supposed to produce what? 62 grams. And if I multiply this by 100%, I get what? The percentage yield. That clear? So if I multiply that by 100%, I get the percentage yield of what? P4. So you can think it should be an answer, right? Greater than 80%, obviously, right? You can think like this now. Look at this. I can take a decimal place back. I can say 5.0 divided by what? 6.2. Just think about this. Right? Just think about 5 divided by 6. What's like 5 divided by 6? You get what? 0.8 and 3.83 something. 5 divided by 6. Therefore, it should be a number greater than anyway 70%. No? So multiply this by 100. No? Anyway, it should be like greater than 70%. Right? So obviously 70-80%, that kind of range. So the answer is going to be what? The second one, because 80.7% is the answer. So you get 80.7% to be what? The percentage yield, right? Okay. Now listen, I'm going to give you an example to easily solve question number 15. Now here we have a plus 2b becoming 2c, c plus e becoming d plus b, a plus 2e becoming 2d, right? So I want to get this equation from these two equations. What can I do? I should add the first equation to the second equation multiplied by 2. If I multiply this by 2, I get what? 2c plus 2e becomes what? 2d plus b. What happens, now listen, what happens if I multiply the reaction 2 by 2? what happens is the equilibrium constant is squared. Okay, so K2 becomes what? Now if I multiply equation 2 by 2, what happens is, I multiply the equation 2 by 2, what happens is K2 becomes what? K2 squared. That you can understand, right? Because K2 means what? Concentration of D times concentration of B divided by what? Concentration of C times concentration of E. Then if I multiply this equation by 2, what do I get? 2D and 2B, and here 2C and 2E. That means D squared, B squared over what? C squared, E squared. Very easy. So can you understand the theory now? When I multiply equation 2 by 2, equilibrium constant is squared. Now listen, next rule. When I add two equilibrium reactions to get the final equilibrium reaction, the equilibrium constants are multiplied to give the equilibrium constant of the final reaction. Once again, when I add two reactions, you can try this at home, check it out, right? When I add two equilibrium reactions to get the final equilibrium reaction, number 3 for example, so I get 1 plus 2 times 2 giving number 3, the equilibrium constants are multiplied to give the resultant equilibrium constant. So listen, I had what? Multiply K1 by what? K2 to the power 2, right? Because I had to multiply equation 2 by 2. That is equal to what? Equilibrium constant K3. So we can use that. So I had to multiply what? 3 times 10 power minus 4, right? By what? K2 squared. What is K2 squared? Yeah. 8 times 10 power minus 4 into the power 2, right? Then I get what? 64 times 3. 64 times 3 is what? 192, right? 64 times 3 is 192. Then I have 192 times what? 10 power minus 12. Then I get 1.92 times what? 10 power minus 10. The answer is not there. So that's why they have given this to be all, right? So you can use this technique, right? Yeah, listen to this again and you'll understand, right? Yeah. Let's do question number 16. So we have bromobenzene and then we have NO2, right? So they're asking, consider the nitration reaction of bromobenzene. Resonance stabilized carbocation intermediates are formed during the reaction. Which of the following is not a resonance structure of these intermediates? So I have bromobenzene like this, right? Bromine, and then I have what? NO2 is plus. Then this is an electrophile, which means it likes what? Electrons. Then electrons are supplied like so. Then what's happening is you obtain a structure like this, right? You obtain a structure like this. NO2 here, and you have hydrogen here. And here we have bromine, and here we have a positive charge, right? Now, can we have hydrogen close to bromine? We cannot, right? We cannot have hydrogen with bromine. Is that clear? So now, you know, benzene means C6H6, right? So what is bromobenzene? C6H5Br. So then 5 hydrogens are represented here. 1, 2, 3, 4, 5. Then that hydrogen has been removed and then bromine is here, right? So then I can't have the hydrogen with bromine, right? So therefore I can remove the answer number 3. So the answer is number 3. It's not a resonance structure, right? Yeah. 17th question. Very easy one. A reaction which is non-spontaneous at room temperature and 1 atm pressure becomes spontaneous at high temperature at the same pressure. Which of the following is correct for this reaction at room temperature? Assume delta H and delta S do not change with temperature and pressure, right? You know this equation. Gibbs free energy change delta G is equal to what? Delta H enthalpy change minus what? Thermodynamic temperature times what? Delta S, which is what? Entropy change. Now listen, non-spontaneous at room temperature, but spontaneous at high temperature. Now listen, non-spontaneous at room temperature. Non-spontaneous means what? Delta G is positive at what? Room temperature. At room temperature, delta G is positive. How is it positive? Okay, now it's non-spontaneous at room temperature. But when the temperature is increased, now listen, when the temperature is increased, delta G becomes negative, because when delta G is negative, what happens? Reaction is what? Spontaneous. Reaction is spontaneous, no? Now listen, think of this idea. If I have delta H to be a small positive value, minus what? Temperature T times what? Delta S. If delta S is positive, now listen to this idea, right? Delta H, suppose delta H is positive, I'm going to give you an idea. If delta H is positive and delta S is also positive, can you see when the temperature is low, right, this product is low, then this positive value for delta H is higher. When delta H is positive and its positive value is greater than T delta S, when the positive value of delta H is greater than what? Product of T delta S. Now, you know, minus T delta S means what? You get a minus value here, right? You get a minus value here. When the positive value here is greater than the minus value here, what happens? Overall delta G is what? Positive, which means the reaction is what? Non-spontaneous at room temperature, because room temperature means a lower temperature. Now, what I'm going to do is this. Now listen, can you understand this logic? If I can make T delta S a large, if I can make this entire term T delta S a large positive value, this minus T delta S is what? A large negative value. If the temperature is higher, what happens? T delta S becomes a large positive value. When T delta S becomes a large positive value, what happens? Minus T delta S becomes a large negative value. Then that negative value will exceed the magnitude of what? The positive value of what? Delta H. Then can you understand at a higher temperature, what happens? In this case, delta G can be what? Negative at higher temperature. So what are the conditions then? So read the question carefully. A reaction which is non-spontaneous at room temperature. If it is non-spontaneous at room temperature, delta G should be what? Positive at room temperature. That's understood. Become spontaneous at high temperature. That means definitely to become spontaneous at higher temperature, delta S should be positive. Otherwise, there's no way, right? So delta S should be positive. For delta G to be negative, right, at higher temperatures, then for this, delta H should be positive. So delta H is positive, delta S is positive, and delta G should be positive at room temperature. It will become negative at a higher temperature. Easy, right? Question number 18. The de Broglie wavelength of a neutron traveling with a velocity v is lambda. The kinetic energy E of this neutron is increased 4 times. The new de Broglie wavelength would be, right? Let's see. It's very easy. You know, de Broglie wavelength lambda is equal to what? Planck's constant divided by what? Momentum of the particle, mv. Suppose we have a particle of mass m having a velocity v. The wavelength of this particle lambda is equal to what? Planck's constant h divided by what? Momentum mv, right? Now listen, you know kinetic energy is equal to what? Half mv squared, right? Now tell me, now they are saying the kinetic energy of the neutron is increased 4 times. How can we increase the kinetic energy of the neutron 4 times? Because now the neutron has a fixed mass, right? So we are going to increase the kinetic energy by 4 times. Then definitely velocity should be doubled. When the velocity is doubled, v squared, that means it becomes 2v squared now, no? V squared becomes 2v squared, then we get what? 4 times the energy. So when you double the velocity, you get what? 4 times the energy, because E is proportional to V squared. Can you understand? Now, lambda and velocity are inversely proportional. If I multiply velocity by 2, that means this is what's going to happen, right? Earlier, kinetic energy was E. Now the kinetic energy becomes 4E. That's because velocity V becomes 2V. When velocity V becomes 2V, lambda becomes what? Half the value, right? You can understand that. Yeah, so we have question number 19 now. Right, what's the question number 19? Which of the following correctly shows the electrolytic cell constructed for the electrolysis of what? An aqueous solution of the salt MX. Very easy, you don't have to even discuss this. It's like an all-work question, right? Easier than all-works, I guess. Yeah, so they give you breathers like this. So the answer is the second one. You know that the anode should be connected to what? The positive terminal of the battery. So this is the anode, right? Anode. This is going to be what? The cathode, connected to the negative terminal of the battery, right? So the answer is going to be the second one. Right, question number 20. Which of the following statements is correct regarding the reaction between a carboxylic acid and an alcohol to give an ester? Now let's see the mechanism to really understand this. Mechanism will obviously explain the. Right, look at question number 20. What can you say? Suppose we have a carboxylic acid like this, CH3, C double bond O, OH, right? Reacting with what? Let's see the mechanism. CH3, OH. Actually, this is what's happening. We have CH3, C double bond OH. You know, carbon is delta positive, oxygen is delta negative, right? Here, if you consider the alcohol, the lone pair of the oxygen is going to attack this delta positive carbon. Then what's going to happen? When you get CH3, C, right? What's going to happen? When the lone pair on the oxygen atom attacks this delta positive carbon, this bond is taken towards oxygen. Then oxygen becomes what? O minus, like this. And then we have what? OH attached. And then we have what? Oxygen, hydrogen, and then CH3, right? What's going to happen then is this lone pair is converted into a bond pair. Then carbon cannot have more than what? 4 bonds. What's going to happen is it's released. The OH is released, right? Then what happens? This oxygen is going to what? Donate these electrons to what? Hydrogen. Then this hydrogen gives this bond to what? Oxygen. They finally form what? CH3, C double bond O, and then what? O, CH3. This is an ester. Ester. So, and then what? We have water produced, right? You can see how water is produced. Now look at this. It's simply we remember it like this, right? The OH from the alcohol and the hydrogen from, sorry, the OH from the carboxylic acid and the hydrogen from the alcohol. We remember it like that, no? All right. So now looking at that, then we can get the answer for the question. What's the answer? The second one, right? Why is it the second one? It is a reaction in which alcohol acts as a nucleophile. You can see that alcohol is attacking what? Yeah, this carboxylic acid, this carbon, which is what? Delta positive. Exactly. So the answer is going to be what? The second one, right? Okay.